data structures. What we had considered in the last lecture, that was just the concept of pointers, okay, which we will be requiring henceforth every now and then. And prior to that, we had even discussed the sparse matrix, which is again a type of data structure, but we have not dealt it in that particular manner. We were mainly concentrating on optimizing the memory required for the storage of the matrix, maintaining the positional relation among the particular items or the values. And then we had even discussed about the matrix operations which are mainly there. If you are looking for some operations like finding the inverse and all, that is going to be very complicated. Standard operations like addition, multiplication and transpose, those are the ones which we have discussed. And you know that the inverse etc. can be found out by some other techniques also. Like you have IA or IAI type of thing where the row operations are performed. But then those typical ways of finding the inverse in case of a matrix which has got number of zeros, probably the actual storage will be much more effective, the matrix type of storage, than the sparse representation. Because in sparse you are required to check when you are subtracting two elements in the same matrix, you are required to check whether they belong to the same column when you are performing the row subtraction as such. And then that factor has to be found out and whatnot. So there will be unnecessary checks which will be coming into picture, and the cost of the operation will go on increasing. It will become more and more complex because you are using a different representation for storage. It will be at that time better that you shift the matrix to the standard form, that is from sparse. Like we have written a function where a matrix is to be converted to the sparse notation. Now you will have to write a exactly reverse type of function from sparse to the standard matrix. Once you write that function, most of the job will be through. So you take it temporarily to the standard form, perform the operation and then take it back. We have used actually that policy in the matrix multiplication, because we have said that, but over there it was not the job of converting the sparse form to the standard matrix, but we were multiplying the two matrices and the result was directly going to the standard matrix form. That is how we have written it. But one additional function you will have to definitely write to convert sparse form to the standard matrix. Then the job will be done. Of course, our teachers are not giving us the assignments which are really based on the sparse application as such. So other than addition, multiplication, simple transpose, fast transpose, you can restrict yourself only to these type of assignments, and even in the exam you will have the same thing. At the most the change could be you can use one-dimensional array, one type, or the second type it could be using the pointers. You will have to do it like the one which we have seen last time. And the third case which we will come across afterwards, after learning the linked list, that you implement sparse representation using linked list. That's it. But the basic concept and basic checks are not going to change any moment. Only thing is whether you consider it as array or whether you consider it as a pointer and use the dot operator or arrow operator, and you will be through. So that will not be a big issue. Like you have declared the sparse as a particular array of 50 elements, instead of that you can dynamically allocate it, but other than that there will not be any difference. In a few colleges, instead of using the structure, they have even suggested a two-dimensional array. When we use two-dimensional array, in that case there will be three columns. First column representing, column 0 representing row number, column 1 representing the column number of the original, and column number 2 will represent the value. The only drawback in that representation is you cannot have the value as float, because then row number, column numbers are integer. Obviously in a two-dimensional representation the third column will also contain the integer value. Okay, so if the application, if they specifically say that use two-dimensional array, then wherever we were saying that sp1 square bracket say k1 dot row, instead of that it will be sp1 square bracket k1 square bracket 0, because it will be column 0. So wherever you had dot row, replace it by square bracket 0, dot column should be replaced by square bracket 1, and dot val should be replaced by square bracket 2. and then the entire program can be transferred. You actually have a facility in the editor to find and replace. Control QA. So you can say control QA dot row and replace it by a square bracket 0 and say go G. And it will keep on asking you whether to replace yes no. So आपको एक एक पढ़ के भी replace नहीं करना पड़ेगा. The editor has that facility. Control QA, find and replace. Similarly, afterwards you will say control QA dot call, replace it by square bracket 1, and then the entire program will change. So it will be as fast as that. Similarly, you can replace sp1 square bracket k1 dot by sp1 arrow to change the program. It will be just a 2 or 3 minutes job to convert the entire program from the one which we have written to the pointer form, or from the pointer form to two-dimensional array. We don't have to search and replace and compile it, and then there could be errors, you have not replaced, anything like that. It won't happen. Okay, only the declaration should be given in the proper form. The things will work very fast and correctly. Now when we talk about data structures now, henceforth, basically data structures can be considered as the collection of data objects along with some specific operations. We are required to handle the data in a particular manner. This data structure concept arises from the real world concept where we are processing the data in a particular manner. We are processing the data in a particular manner. For example, the standard case could be queue, where we normally stand in the queue and on our turn the particular tickets could be purchased, or you can enter the bus and whatnot, which is one of the common phenomena. Now even when we put the request to the machine, to the computer, to process the data, for example in banks where there are multiple terminals, or even in the railway reservation when there are multiple terminals, whenever the data is entered, whether you will be getting the reservation or not, it will depend on your position. Of course that queue, the system queue, will be really moving fast, whereas even there is a queue which is a physical queue when you are actually standing in front of that row. That is, till your turn comes, it's the physical queue. The moment he enters the data, that is, you are looking for so and so train and so many seats, at that time from all the other terminals even some requests are put. So those will be put in the system queue and that data will be processed. By chance on both the adjacent windows, both the persons are looking for some Deccan Queen seats on the same date. In that case, if only 3 seats are remaining and both are demanding 3, then one of the requests is likely to get denied. It will be the one who presses enter first will enter the queue fast, that is the system queue. And then he will be allotted, whereas your request will be next and you will be denied. That type of thing. So when we are talking about the data structures, we should be basically looking for the actual representation or the real world representation and the rules. Like in case of queue, we generally don't allow anybody to enter the queue somewhere in between. No, that is not allowed. Though it happens, but that is not allowed. Even the other case, like somebody might feel very irritating to stand in the queue and he may leave in between. But when we think of the queue as a data structure, then we will not be allowing the data to leave just like that. Once it is entered, till its turn comes, it should remain in the queue and then it will be removed. That type of thing. Okay, so we will be talking about a linear queue, not a queue which has started and then there are branches, like not of this type also. So there could be one window, but then there are 3 queues. That's not going to happen. Got it? This is one case. Another thing that is our today's interest is something called as stack. You have heard the word stack? Unlike queue, when we see a particular stack where the things are put one over the other, we will be always processing the data at the top or the object at the top. Example, books, but you do remove the book at the bottom, which we will say is not allowed. You can count how many books are there. Actually, it is treated as a container in which the things are dumped. So you can see that thing which is at the top, but you are not aware as how many things could be below it, or what are they, or how many of them are there. Such an answer is not allowed. You can put new things, you can remove the thing which is at the top. Simple concept, stack. Stack can get empty, and at times the stack can get full. It will depend on the size of the container. If it is a predetermined size, you can have infinite stack also, possible. Then similarly, in case of queue also, you will be putting the data from one side and removing the data from the other, like a pipe or a tunnel. Okay, so they will be put one after the other. Again, you can see the item or the person who is to be processed. Okay, and you can see the other end of the queue, but again you are not aware as how many persons or how many data objects are really present in that particular queue when we are talking about the data, though that information can be gathered. But we say that for processing there are only concepts like queue is empty or queue is full, which is the end from where the processing should be done, which is the end from where the data should be added. Okay, and every data item over here can see who is ahead of him, who is behind him. But then that particular data is not going to depend on the item which is ahead of it and item which is behind it, because somebody else is going to process it. Got it? That particular data, whether this person is asking for 4 tickets of Kal Ho Na Ho or not, that is no way going to give the information to the next person as whether he could get the tickets. It's of no use. The final answer will be given when that term, that particular data actually appears, and then what? Okay, so it will be the system who is going to process that particular data, right? But the data has to be preserved because it is going to appear in a particular sequence, whether you want to maintain that sequence or not. Like you people could be working on LAN and the actual compiler could be present on the server. Whenever you send the request to compile, probably your program will be transferred to the server, it will be compiled, and then the file will be transferred back. Okay, the earlier LAN versions. Over there, it might happen that for somebody the program can be getting compiled very fast, and for somebody it might take a longer time. It is not dependent on the distance from server, but it is the time when you put the request, and what is the actual policy which is set to that particular server. Because though all the 30-40 machines are on LAN, there is a facility by which I can give the priority to a few machines where normally the staff members are working. So 2-3 machines, they will be named as the priority machines, and the others are standard. So for all other 26 machines, the request will be treated at par, one after the other as it receives. But 30-40 people, they are sending the request, and somebody sitting on one of those 4 machines sends the request. His processing will be done very fast because he will be processed on the priority basis. He might be going through that, but might not be going through that queue. So there will be a concept of priority also that could be there. Okay, like instead of standing in the queue, there could be a phone booking. But when you think of phone booking also, it will be a queue. The one who calls first, his tickets will be kept aside, then your call. Okay, but in that case, when you actually go to that ticket window, probably you can directly fetch it, or there could be some other mechanism. but the processing will be done on the priority basis. It's not when you physically reach the theater, okay, because you have already set your priority. Priority of this particular processing is already set, whereas those who are reaching directly, they will be at the least priority, that way. Okay. So these are the concepts where you will have to remember. Of course, in queues this priority concept exists. In stack it does not, because going inside the stack, that will not allow us to fetch it. So there cannot be something called as priority stack, but priority queue concept could be there. So stack can be considered as a data structure where the data will be processed in what is known as last in, first out. LIFO. Concept: it is a container which is closed at one end and open from other. So we say that the stack has only one end, and the same end is used for storing and processing. So data can be added at top or removed from top. And stack can be full or empty. Stack can be full or empty. The stack is not full, that means it doesn't mean that it is empty. Though you treat these as opposite words, it's not like that. Stack is not empty, it does not mean that it is full. Okay, because it could be partially full. Okay, so both the conditions matter, whether it is full, but that will only provide the information that it is either full or it is not full. It does not inform us about whether it is empty. Not full indicates that there are some empty positions, but so far as the entire stack is concerned, we cannot predict anything. We can check whether the stack is empty. If it is empty, fine, all the positions are empty. If it is not empty, then we don't know whether it is full or not, because a few positions could be occupied and the rest could be empty. So what we are asking over here is stack to be full or not, full or empty. Okay, not whether few positions are full or not. No question like that. This is the base, and we now list out the operations on the stack. One, we call it as push, that is to add the data. Second one, pop, that is to remove the data. Third one is stack full. It's a question to be answered as yes or no. And the fourth one, stack empty. So we can put two questions, we can perform two operations. And this as a whole will be implemented by some other program where the actual processing is done. Can you give me one real world example where the stack is used, where it shouldn't have been used, but it is used? अगं रिअल वर्ल्ड एक्झाम्पल पाहिजे. ईमेल मध्ये कुठे सांग बरं. ईमेल मध्ये कधी कुठे कुठला स्टॅक. In a printing press, yes. Not only in a printing press, even your computer printer also, DeskJet printer. You put the stack of the papers and the paper at the top will be the one which is going to get printed. It's a box. No, but this is, I was really interested in the processing. That one by one data is removed and processed, and then the entire सीडीचा बॉक्स पाहिला नाही का 100चा आहे दाखवतो वाटलं. काही करता येत नाही. That is a real application where you cannot remove some CD from in between. Okay, printing press, it is the same thing. That one by one the paper at the top will be removed and will be pressed. Another application where the stack is implemented and we feel very irritating is like there is a big queue to submit the exam forms, and they just say that okay, submit, I will give you the receipt, and the first one gives the form, then the second, and it is stacked, and then he gives the receipt to the topmost one, and that is something which is very irritating, where the stack shouldn't have been used. Earlier application was a queue. So the first person, he will have to wait till the longest because his form is stacked, it is at the bottom. Okay. Generally what they do, they take the form and put it river, and then they stack it, and then they revert the entire thing. These are the applications where we see that the stack is being formed, stack is reversed. Whether we can do it over here, it will depend. As an operation, we don't allow the stack to get reverted because the basic policy is last in first out. Okay. So even if he collects the forms and put them in the revert manner, if it is purely stack application, it will be still the last person's form which will be processed first. असा ठेवला का असा ठेवला याला काहीच अर्थ नाही. The one which is at the top. The only option, you should start collecting from the end. That is one policy where now if you go for the railway reservations and all, or even at the election time, when the time is ending, at that time they give the token, and that token is not given from the first person as 1, 2, 3, 4, but the tokens are issued from the last person, so that no one else can be added to that particular queue. That's a stack of tokens actually, from the last person to the first one. That's it. So we know that there are 43 people, and then 43, 42 like that the votes are collected, or even in the other things. Normally at the end of the time the tokens will be issued because those many people, they are present before the time, so they should be given the chance. This will become the application of stack in that case. We are fixing up the bottom of the stack in that case, and the actual application was a queue earlier. Till that time it was a queue. After that it became a stack, and then the last person is at the bottom of the stack. Got it? So keep your eyes open, and then you can find several applications. दरवेळेला तेच ते पुस्तकन CD सांगू नका, because over there is no processing. तुम्ही 5 विषयाची पुस्तकं घेतलीत म्हणजे काय पहिलं घेऊन वाचायचं मग दुसरं असं नाही कर. So there is of no use. Correct? And that too, even the pages of the book you don't read in the form of queue, first in first out, page 1, page 2. You again read it randomly. That too, you go to the end and check how many pages are there. Even that counting is not allowed. Okay, so here is our first application, first data structure, stack. Now saying something like this, that there is a storage, the data should be stored and these operations are to be performed. This is the entire abstraction. I am not yet using any word from programming. Though I might say it as push, but it means add. Add to the storage, remove from the storage, check whether storage is empty, check whether storage is full. So you require storage, you require operations, and this can be collectively called as the abstract data type. Now, how do we represent it? It could be your first assignment also, that implement abstract data type stack, something like that. You can simply forget these words and whatever we discussed today can be treated as the program. Only thing is it should be named as a program for abstract data type. Okay. But this is what we call it as the abstraction. Abstraction will be normally from the real world concept and then it is to be converted in the programming form. And then two entities will come into picture, the storage and even the operations. And when we say operations, these and these operations. Other operations should be treated as illegal. Though it is possible to count how many elements are there in the stack, one should not. Though it is possible to revert the stack, one should not. Though it is possible to remove the element at the bottom and process it, you should not do that. That's a restriction. That means the abstract data type as such, when you declare something as stack, then there are restrictions also. Whereas as a programmer, you can practically do anything with that. You can temporarily forget that it is a stack and you can process it because you have the access to the storage. But rewriting the program following these restrictions will be the implementation of the data structure. If you forget them, then you are not implementing data structure. Then there is going to be some mix-up of the storage that you have, the memory that you are handling, and your logic. So we start with the first job, that is implementing stack. Of stack using array. Implementation of stack using array. Now, I will go for declaring, say, struct stack I suppose this is what we have already seen in the sparse, that is struct sparse, some data objects within it, and a new type is declared. So here I am having type def struct stack some data. The new type is stk. So I am writing the code entirely in the general form. Okay, fine. Now here you can have one data item, multiple data items, whatever. Like you can have the entire combination, student database hai, and if the data is to be kept onto the stack, then it could be name, roll number, everything. If you want to deal with only float values, you can have some data type and val. So I will be writing the code assuming that there is some type that is already there and it is val. So I will do the job for val. If you have multiple things over here, name, roll number, etc., then you will have to fill in all the positions and then dump the entire thing into the stack. Though I will be writing it for val. So whatever job I do for val should be done for roll number, should be done for M1, should be done for average, should be done for result, and so on. But not push operations for all of them. You will have to fill in all those and the entire thing should be dumped. हर एक के लिए पुश नहीं करना पड़ेगा, बिकॉज दैट एंटायर द थिंग विल बी अ सिंगल एंटिटी विच इज टू बी पुश्ड. Getting it? Any doubt? Any doubt? Or should I go for the simpler version only first? Okay, we'll go for the simpler one. Stack of integers. So we will be storing only integer values into the stack. In main, I will have to allocate the memory. Okay, so as I have said, we will be using array. I will say int stk of some size. Whatever I write in capitals should be hash defined. So you declare whatever is the size. So this is going to be one array. Last one is going to be size minus 1. Now how do we implement stack into it? One end should be assumed to be the closed end. तो आडवा काढला म्हणजे स्टॅक होणार नाही असं नाही. हां. It need not be always like this. It can be even considered like this. It is still a stack. Barabar? And so when I put one item, this position will be filled. When I put one more item, this will be filled. When I put one more, this will be filled. When I remove one, ultimately I will have to keep the track as what is the last filled position. And that track will be kept by top. Top is nothing but the position in this array which will tell us as where is the last element placed. So now the top will be over here. If I add one more item, top will increment. If I remove one item, top will decrement. Fine with everyone? When top reaches size minus 1, stack is full. That array is full means stack is full. You cannot add any element. Can you tell me when will that stack be empty? Less than 0 or just before 0. Because if you put it as 0, it means that there is one element present. It is the last filled position. So this will be 0, one value is still there. We will put it as minus 1, and whenever we create the stack, it will be empty. Okay, so initially top should be having minus 1 as the value. This is what I have in main. Right? And now two simple functions which you have only told me. First is int stack empty. What will be the parameter? Do I require array to check stack to be empty? No, I require only the position of top. Okay, so the parameter that I will pass is top, and it will be if top equal to minus 1, return 1, otherwise return 0. On the same lines you can write stack full. If top equal to size minus 1, return 1, otherwise return 0. Two basic conditions.